IAT Psych. Let's go ahead and do some review images again. And let's share the screen. This should be the fifth one we're going to do. And I will try and keep it somewhere around 20 minutes so that you can pause, see what you can recall, and then continue with whatever it is that I might add to it. Make sure these are all things that you would be able to recognize, pull out of memory, or hopefully be quite familiar with. Again, even though you're going to have the ability to have notes at your fingertips, you will absolutely not be able to look everything up. That is the purpose of the design with this. So you're going to be able to access some additional information that you will have with you, but absolutely not an adequate amount of time to look everything up and find everything. So you want to make sure you've got the ability to have these concepts in mind, hopefully contextualized. So like what chapter, what person, what things would be tied to it, that sort of thing, as you're going to go ahead and continue with a pretty odd exam. But we'll be talking about it again, and I will also, I'm thinking not this week, but the next, be doing something over recommendations on how you should be setting your notes up so that you can access them and use them to your advantage. Okay, here's the first image. How does parallel processing operate? And if you don't have the idea of parallel processing in mind, what is it and what would be the opposite of it? This is how your brains can actually work through stuff. When in this case, we're looking at 4 images. So if you see a thing, how does parallel processing operate? And these 4 images would be at least 4 options of examples for that sort of functioning. Okay, first of all, what is parallel processing? It's your brain's ability to do multiple things either at the same time or simultaneously. So you don't have to, the opposite of parallel processing would be serial processing. So you thinking through things one step at a time when you're going to do something. So if you were, say, cooking in the kitchen, what do you need to do in order to make eggs or make your breakfast or whatever in the morning? First thing I think of to go do is grab toast. Since it's going to go in the toaster, it takes a while. I do that thing first. And then the next thing I do is I'm going to get a pan. I'm going to turn on the pan. I'm going to break some eggs. I'm going to cut up any vegetables or whatever I'm going to put, right? All of those things one at a time, as opposed to the opposite would be parallel processing. So if you're looking at an image, say this thing, if I'm looking out my window here, I get a bunch of birds in one of those bushes. I see this thing here. I'm going to notice the following things all at the same time. And I don't have to think about them differently. That image is going to get put together or processed parallelly, simultaneously at the exact same time. So here's one thing. The motion, in this case, the illustration here shows flapping of wings. And I don't have to think about the difference between motion and form. So like the outline here, you've got feet, you've got a bill, you've got wings. In that case, there's one in the foreground and the background, and you've got tail feathers. Putting that together with motion, it just all looks like one thing. You don't have to think about them differently. You also get a sense of depth, the shading here, the 3-dimensional look to it, light and shadow, that sort of a thing. And for this particular image, you would get at least some color. There's a bit of Buffy or Rufus right there, almost like a red, kind of a hint of yellow, dark brown, gray, even almost a black right in there. So those things automatically go together, and you don't have to think about them separately, 1, 2, 3, 4, 5. It's just all going to be one thing if we're talking about parallel processing. That's a perception phenomena. Here's another one, something we would have seen before. First of all, what is it? It's called a Necker cube. And then the prompt for image review that I pulled off of some of the stuff from our textbook here would be, how does the Necker cube illustrate Gestalt or Gestalt? So if we're looking at the image right here, you should be able to see a square and a square fore and background, and then you also get all the ones on the side, so it turns into a cube, 6-sided right there, and a couple of different things before we address just specifically how the Necker cube illustrates Gestalt. Some of the things we would have talked about in class about it from forever ago would have been, depending on how you look at it, you should be able to see if this great example of a square. If you're looking at this one down and to the right, and I have that one be in the foreground or front nearest you, you should be able to also switch it. So that goes to the back. And again, one of the things we would have talked about is how many ways can you see it at one time? And the answer should be one, as you are only able to actually single task or do one thing at any given time. One way you should be able to do that. You should also be able to perceive this thing as having a third dimension, even though it's only going to be 2D flat right there. And if we're talking about how does this Necker cube illustrate Gestalt, well, you get a bunch of things that are not actually in and of themselves going to be what it is that your brain puts together as the whole. So the Gestalt is the idea that your brain's putting stuff together, putting things together into a meaningful whole would be the literal definition for it. So even though your brain should be able to pick up and see this as what looks like a three-dimensional cube, clearly it's not a three-dimensional cube, nor would any of you be fooled into thinking that that was the case. What is it that you're actually looking at? Okay, well, we're looking at mostly a white background. And then what we've got, your brain typically perceives, but even though it's not going to be accurate, is this circle being a circle. It's not a circle. You've got kind of a triangle, and then you've got a Pac-Man that's going to be open there, and then a triangle thing. But it gives the illusion or the hint. It tells your brain what it should actually do is connect so that you would have a line there, which is actually negative space. It's not a line. It's not a thing at all, but your brain puts it together. Your brain needs to interpret it as something that makes sense. That makes sense. A cube makes sense. A three-dimensional object or something like that makes sense on a 2D background here. Necker cube. All right, another object. Okay, we've got a couple of different things going on here. Figure ground is the first thing I would hope would come to mind. And then if we're differentiating or looking at the what those things are, figure front. So if we say the figure front, I'd like the black image or black portion of the image to be the figure in the front. Now you're talking about two faces. You got a nose, lips, chin on the right side, and then the left side, you've also got same thing facing opposite. And if we switch it, so we're gonna make the black, the background, and the front, the figure, the white. Now you end up with vase or a chalice or something like that. And again, it's one of those things that you're able to pick up on. In this case, for individuals who would have been without sight and then later gained it through some sort of recuperative operation. In that case, this is still one of those things that you can pick up on immediately. Potentially difference in color stuff, also a figure, something in front, something in the background and whatnot. But what a shape is not the case. So strangely, that wouldn't translate to, if we jump back and look at the Necker cube here, if you've got something that's going to look like a circle or maybe feel like a sphere, we, assuming you're regularly sighted, always assume that that object is exactly or is analogous in your mind. If you hold a ball, you figure it looks like, and you feel it, and you put those two images together as the same thing in your mind, but that's not actually the case that we would find if you end up getting sight later. But the ability to differentiate one thing and then another foreground, background, that is something that you would be able to do. All right, here's another thing. We've got sticks or vertical lines, and you've got a grouping of them. Your brain naturally puts things into groups that it tries to make sense of. And in this case, this would be illustrating, I would hope you would think of as a proximity. So how many do we have in total? We've got 6. We got 2 off to the side, 2 slightly closer in the middle, and then 2 over there as well off to the side. That proximity usually causes an individual or causes people to try and group them together. So it's not 6 different ones because of the spacing. Because they're proximal or close to one another, usually you put them in groups. Where's it going? Okay, I would hope that you would look at or see continuity, a continuous straight line and a continuous, in this case, it may overlap, it may join, doesn't necessarily matter. What we're looking at here, like a sine wave, you see those as continuous and unbreaking. Your brain just puts it together. It's a perceptive phenomena. Nice one, kind of like the Necker cube we just talked about. Odds are, if you're looking at this thing, you see a triangle. Your brain closes it off and finishes, or even if you're talking about the negative space, the white triangle that's going to be overlapping here in the background, you've got what looks like 2 concentric circles, one on each end or point of the triangle. So it looks like you've got a couple different ones there. This one closing it off slightly differently, this one being an open version of the same thing. Okay. So we got a bunch of different things going on here. You've got literally, this is called a visual cliff, and it would be an indicative thing for toddlers, for those that start to be able to move around as soon as infants become mobile. If we're talking about humans in particular, that visual cliff becomes apparent once they are able and moving around. And it takes just a little bit of time, and then they gain the ability to demonstrate or show, if they come up to that point in the visual cliff, that they'll stop. They won't just go right over. In this case, it's not going to be an actual cliff. There's no chance of them being harmed because the plexiglass or whatever you're going to put over it continues over, but you'd want them to show by stopping, showing their behavior. Since they can't talk, they're infants without speech. So at this point, that the little checkerboard go, and then drops and then continues down. So for their own safety, they should quit moving at that spot. And now if you're talking older kids, they'll test it because they're going to be the best possible natural experimenters. They're going to put their feet over, they're going to tap on it, or you know, the question would be, are they old enough to gain trust that mom can communicate that that's a perfectly fine thing? Yeah, you're able to keep going. Or if they're too young and they don't notice the difference, they don't notice that there's a change in that there is a depth thing happening that could cause them harm, then just climb right to their death because they trust mom and mom's horrible. Ooh, great one. Okay, the phenomenon we're looking at here will be one that happens because of retinal disparity. The difference in your two different eyes causes slightly different images cast into your central nervous system and then interpreted differently. We talked about this in review already. So that image is going to send slightly different things onto your brain. And you end up with, if we're talking about the sausage fingers here, because of retinal disparity, let me draw on it, where you end up with an overlap in your visual field is where you get that false extra finger thing happening, right? This appears here where the overlap takes place. And I know I'm drawing on his mouth. It's just because the image is a little bit small, so I apologize for that. But where both of your eyes are going to be doing a thing is where this thing comes in. You're accidentally doing a composite image right there. So it would only work as a binocular thing, a binocular cue for depth perception, that difference in your eyes. If you wanted to display this or show this in some sort of an experimental setting, you should have individuals who, if you're going to just play toss and throw a ball, it's easier to catch if you have both eyes able to see that, because you're tracking the image twice and they're checking with each other as the ball moves, as the size change, as the velocity is going to be, you know, increasing, decreasing, it goes up, it goes down, it does whatever it's going to do. So if you do that with two eyes as opposed to trying to do it one-eyed, you'll likely find it to be easier. Individuals who, you know, depending on how you're throwing the ball, what speed, where you're at, that sort of a thing, are a little bit more practiced, will probably be able to catch a ball even with one eye, or just one hand, one eye, that sort of a thing. But it will be a difference in difficulty because of, clearly, your two eyes, retinal disparity. Okay, a couple different ones you could think of right off the top of your head. I'm going to give you a prompt with it though. So the textbook question to go along with this image for sensation and perception stuff was, what is relative height? In this case, for this image, what they're hoping that you would typically do is look at things and see if it's going to be high or up above, like the white here. It's going to be away, further away, farther away, because you assume that the lower part of the figure is a thing that's going to be a closer thing. Turn the image up and down. It's a night versus a day sky thing, but you'd have ground and then you'd have up high. Not the most impressive, but you could also see something like figure and ground in here if you're talking about ground and sky. But in this case, we're looking for the relative height. Up above versus down, and down below is the way your brain typically tags those sorts of things to try and make sense of it. All right, I'm going to guess this one's going to be asking us, yes, what is interposition? Okay, We have two, to the best of my knowledge, those are deer, two deer. Which one's in front? The one that you can see the full figure of, or the full form of. If it's in front of, or if it blocks or occludes the thing there, then clearly that one's going to be farther away, and this one's going to be closer to us, and you have an ability to pick that out or see the difference for. If you don't know which hand is going to be closer to the screen, as soon as one blocks the other, clearly the one in front will be the one that you can see the whole outline for, and the other one's going to be in the back. Okay. So let me give you a minute. Okay, if we're talking about this one, it's going to be a perception of movement issue as you are moving in one direction. If you've got some sort of fixed point that you're going to be looking at, you're going to notice that there's a difference. It's called motion parallax. Might as well type it for you real quick if you need to add that to your notes, or if it's not something that you were able to think of on your own. And I will make it visually available. Motion parallax, parallel, or those two or more images here. If we've got somebody, say they're on a bus, train, whatever it is, and you've got a fixed point, the things below it or the things nearer to you will be going by super fast. So say the boulevard, the sidewalk, that sort of deal. Things in the background will seem to move slower. So these things are going as this thing's going to be a little bit slower. And then if you have mountain ranges off in the background, those mountain ranges will be in the image or in your visual field for an even longer or in a more extended period of time. That difference, that disparity in as you're moving, if you're a passenger on whatever it is that you're on, that difference lets you know motion, and also how close or how far things are away. Again, the things that are closer to you will be going very fast. The things away won't be going so quick at all by comparison. Here's a good one. Going on, and it looks like that up there. So the question for this one is what is linear perspective, or what do these lines do? These lines are illustrating linear perspective. We've got a vanishing point there. So as the road goes up and it appears it would be going, let me switch to blue so it highlights a little bit better, up and away. The road should get smaller as it goes from you. So you've got a wide road down there. It also says road narrows, although it shouldn't make a difference on the illustration for the image, for the visual here. It's reinforced in the second one there, where you've got, if this is supposed to be the same car, that same car appears to be much smaller as it goes away. These lines, this linear perspective off to that vanishing point is, in this case, a visual cue for depth, right? It gets small if it's up there, and it should be big if it goes there. I think in class I showed you at least one or two examples of what look like monsters. The monsters are the exact same size, and whether it's down here or up here, if it was up high, it looks like it's taking up a different amount of space. So it looked like as the vanishing point down a hallway was going to be, you have a monster that appears big because he's taking up more of that space, and then as he shrunk down, it looked like he wasn't taking up as much in that tube, in that hole, as it was going to be going away from you. So it looks like big monster chasing a little monster, even though it was just going to be the linear perspective. It just looked like what was in the background. Skipping too many. All right, here's a good one. Light and shadow, what is light and shadow? That's not a hard question. Light and shadow should be bright and dark. What does it do for you? Well, now if we're talking something like this, if we didn't have the little any dimple thing in there, we have a round object and we've got some color to it. It shouldn't look like a circle. It would look like a ball or a sphere in that case. If we add light and shadow, it helps to reinforce that perception of thinking that whatever it is that you're seeing, whatever you're looking at, is going to be three-dimensional, is going to be a ball or a sphere, and not just a circle. You add the dimple in it, now you get some sort of extra light and then shadow or a depth inside of there, and now it looks like it's extra three-dimensional, extra impressive, what have you. Same sort of thing, just illustrated upside down on that one. Okay, so I'm looking at 20 minutes just over here for the recording so far. So I'll hit stop for now. I'll plan on doing this probably for at least several days this week. And then if I get any feedback, if there's something else you're hoping for, you want to do, maybe we'll switch it up. I hope you guys had a good weekend and this is useful for you. Let me know if you have questions. Let me know if you need something from me. I will be around. All right. Have a good one.